Hey everybody. So this is just a follow-up from today's lesson. So sorry for having a brain fart right at the end there. So it turns out that I actually was right at the end there. But Kevin, your question was fantastic. And hey, I just needed to rethink, make sure that everything I was telling you was good. So basically, let's just recap what we had. So we were basically comparing the number of people, telling the alphabet, and then the time that it took. So the goal here is what is the best fitting regression line? So sometimes it is linear, but based on the pattern of the data, it could be needed that we have to implement a transformation, either based on exponential or power forms. Okay, so I'm going to take you through that. So let's go ahead and just check that it's linear first. So I've got all my data in L1 and L2. So if I go ahead and do a scatter plot of that data, there's L1, there's L2, and then I do zoom 9, it looks roughly linear, but I'm a little concerned here by the fact that we have a slight curve going on, which may be either exponential or power. So let's go ahead and check the residual plot. So remember, we're going to do a least squares regression first. So go down to 8. All my data is in L1 and L2, and we'll calculate the least squares regression line. So I'm going to get the predicted time is negative 21.059 plus 4937 multiplied by the number of people. The R value is 0.966. That's a pretty darn good correlation there. But let's just check the scatter plots. So the scatter plot of the data, okay, like I said, it's roughly linear, but let's check the residual plots. Because I've done the linear regression, I can go ahead and calculate the residuals. Go to Stat, and then go to Edit, and then we'll go to L3. We'll do Second List. And then we're going to go down to select number 8 in my case, which is the residuals, and then press Enter. So now we want to compare L1 and the residuals. So we'll go second Y equals L1. The residuals were stored in L3, and then we'll do zoom 9. As you can see, we have a curved pattern in the residuals. That is indication that there is not a linear correlation here. So therefore, a linear model would not be appropriate. We want random scatter. This is curved. So let's see if we can do a transformation and see if it might be exponential or a power curve. So what I do is I go back to my tables, and in L3 this time, I'm going to take the log of y to see if it's going to be exponential. So I go here and I press log, and then I do L2 because that's where all my y values are. Close parentheses, and I got all my log values. So let's go ahead and calculate the least squares regression line. So we'll go to Stat. Let's get out of that actually. We'll go to Stat, Calc, do number 8, but this time it's going to be L1 and L3. The time versus the log, the people versus the log of the time. So go down to Calculate, and this time I get an equation of this. Now, the R value has dropped slightly, so that's actually less of an indication that there's going to be a correlation here. But remember, we're trying to see if it's linear. So let's go ahead and do the scatter plot. So do second Y equals. We're going to compare L1 and L3, and we'll do zoom. Oops, get out of here. Zoom 9. So it's roughly linear, but not as good as the original one. So I'm starting to lean towards the fact here that it's maybe not going to be exponential. But again, let's look at the residual plots. So I've already done the regression. So I go to Stat. I go to Stat, go to Edit, and this time we're going to go to L4, because remember in L3, that's where I have all my logs of the times. And we're going to do Second Stat, which is the list, and we're going to residual, and then press Enter. So these are all my residuals. So now we're going to compare L1, which is my population of people, along with my residuals. And we'll see if there's any random scatter, or we'll see if there's a pattern. So go back here, there's L4, and we'll do zoom 9. As you can see, we still get a curved pattern. So that's an indication that an exponential transformation is not a good fit. Now, by the way, if it was a good fit, this would be how you would write it. We took the log of the time, but we still have to write down the new values for A and B, which I've placed there and there. So you don't use the original ones. And that was what Kevin was asking in the lesson. So I'm just clarifying that. You use the new ones that the new linear regression function gave you. All right, let's finally look at power now. We know it's not going to be linear. We know it's not going to be an exponential transformation. Let's see if a power transformation will work. And that's where we take the log of x and y. So we'll go here to my stat again. I'm just going to go ahead and clean out 3 and clean out 4. So remember, all my original data is in L1 and L2. So I'm going to make L3 be the log of all the times. I'm sorry, the log of all the people, or the log of everything in L1. So we'll do second L1. And then I'm going to make everything in L4 be the log of L2. Okay, so now we have log of people in L3, log of time in L4. So let's go ahead and create the scatter plot first. So second y equals, change this to L3 and L4, and then we'll go ahead and create it. Now look at that. That's a much better linear scatter plot. So it looks like a power transformation might be the way to go. But again, let's check the residuals. So we'll go to stat, calc, and we'll do the linreg a plus bx. And remember, this time we're doing of L3 and L4. Okay, and I'm going to write this equation down. So remember, it's going to be the log, the predicted log of the time equals, we've got our negative 0.076, that's our y-intercept, plus our new slope of 1.469, but this time I multiply it by the log of the people. Now look at the R value there, 0.988. That's the closest that we've had. So this is a good sign. But remember, we've got to check that residual. We want that residual plot. We want random scatter. Because I've done the least squares regression, I can go to stats and then go to edit. And this time I'm going to store my my residuals in L5. So we'll go up and highlight L5. We'll do second list, and then we'll type in the residuals, and it gives us all the residuals. But I want to compare the X list to the residuals. In this case, it has to be the X list of the new values, the ones that I just did the logarithmic function of. Okay, so we're going to do, let's go back here, second y equals. So remember, all the logs of the X values are stored in L3, and my residuals are stored in L5. It takes got to really be organized here. Keep it all in your brain. All right, and then we'll do zoom 9. And if you look at that, we do have random scatter. Okay, now there is obviously, the variance is a little bit off here, but we have the random scatter. So therefore, this model right down here is the best model to use. Okay. All right, now let's just take it one step further. Let's say I was asked to calculate something based on this equation. Let's say I wanted to know how long it would take 20 people. So I got my equation right here. I put 20 in for the number of people, and then I figure this part out. So on your calculator, get rid of this, you're really just typing in log of 20. And that gives you that gives you this part, and then you're going to multiply that by 1.469, and that'll give you that 1.911 that we have there. So add it to the negative 0.076, you get this 835. So now we want to solve it. So if you remember back to algebra 2 or pre-calc, the base of this logarithm is base 10, and the way you convert, or the way you solve a logarithmic equation, is you need the inverse of that, which is an exponential equation. So we start with the base, we wrap around. So to convert it, it's going to be 10 to the power 1835 is going to equal that predicted value of t. So therefore, on your calculator, you can just do 10 to the power 1.835, and that's where we're getting the 68.394. So our predicted time for 20 people based on this model is going to be 68.39 seconds. All right, I hope that wraps things up. Sorry that that was I lost it. Like I said, sorry that I had a little bit of a brain fart at the end of the lesson there. If you have any questions, please just reach out to me. Thanks very much.